Hello, today I'm going to present a tutorial on Great Tables package in Python that was developed by Rich Ian Noon and Michael Chow from MIT. It's a licensed package. And with this great package, anyone can make wonderful looking tables in Python. It is created so users can construct a wide variety of tables by working with cohesive set of table components. You can mix and match things like header, footer, attach a stub, which contains row labels, arrange spanner labels, which are equivalent of Excel merge cells over top of the column labels, and much, much more. You can also format cell values in a variety of different ways, like colors, frames, and so on and so forth. This package is designed to be both very easy to use and straightforward, but very powerful. So the emphasis is on very simple methods for everyday display table needs, but powerful when you need it. So here in this diagram, I can show you the typical component of a table in Great Tables package. So here we have a title, we have a subtitle. This is the spanner label. As I mentioned, this would be the equivalent of merging cells horizontally, where stub head label is merging cells vertically. Then here's column label. Oops, sorry. The second column label. Here's the different type of column label. We can format different cells, and we can group rows and basically a lot of other things. Also, we can create footnotes and additional source footnotes. So all the data first is presented in pandas or polars data frame format. And then we further, after importing that data frame into Great Tables, we can manipulate the data and create tables, and I'm going to show you how. So first I'm going to show you a few slides just with the general information about this package, and then I'll proceed to go over Jupyter Notebook with some code example. And on a side note, so I did not write all this code myself. I just basically copied some examples that I could find online. So I will reference all the sources at the end of my Jupyter Notebook. So whatever proprietary intellectual property there is, that's going to be referenced and protected. So there are 16 built-in data sets provided by Great Tables. So in my Jupyter Notebook, I worked with quite a few of those. For example, SP500, Pizza Place, Exable, to name a few. But other datasets include Country Pubs, SZA, GT Cars, famous dataset, Townie, Peeps, Films, Metro, Gibraltar, Constants, Illness, Reactions, Photolysis, and Nuclides. So the installation begins, as always, with pip install. That can be done in like Jupyter Notebook, or you can go and do it from command prompt and a Conda PowerShell. So there are different ways to install the table. Great Tables, there's nothing difficult about it. It's worth mentioning that the package itself was inspired by our package GT, and what I really like about it is it's even written in a very similar format. It's kind of nested code where you can see each component can be modified separately, and methods, what I really like is methods can be used in any order, just like in our language. The package has a few resources. It has GitHub. Here's the page reference to GitHub. It also has its own X and Twitter account and Discord server. So it's a pretty popular package and very easy to use. So here are the citations. So as referenced in the main resource, basically, if you ever want to use it in your research product, just copy this text and insert it. So now I can proceed to the Jupyter Notebook. So I did already pre-install those packages on my laptop. So I just kind of, X'd it out. So it's so we need package to install Great Tables and Polars. So the Great Tables package is designed to help users create visually appealing and highly customizable tables with ease. By leveraging cohesive table components like headers, footers, as I mentioned, and formatted cells, it transforms data from pandas or polars data frames into very elegant and customizable tables. So quick overview of polars, what it is. It is a data frame oriented library written in Rust, and it offers high performance and efficiency for data manipulation and analysis. So it's primarily designed to handle large data sets, and it's very fast, so it provides speed advantage over libraries like traditional libraries like pandas. So let's start by importing a few functions. So for example, we're going to need GT, which is Great Tables Specialized Object Function, and MD, which is Markdown. And then we'll go ahead and import the first dataset, S&P 500. So then we'll import pandas, and let's create our first table. So in this package, we can basically pull the data from pandas data frame into Great Tables table, and we can filter it by start date and end date if we previously cast it and set the values here. And we can basically, by applying certain filters, like I mentioned, the date, start and end, and then creating a display, we'll see our final table. So see, this is what I mean, that it looks kind of like our code. So of course, you can do this. You can combine all those entries, but it's visually easier to see different parts of the table by separating rows. So we can modify header, format different columns, and that's what we're going to do first. And here is the output. So very easy to read, visually, very efficient table. So second example, for that we'll use built-in pizza dataset. So this is what it looks like when we cast it into pandas data frame. It's a pretty standard view of the table. So it contains 49,574 rows of 7 columns. So let's extract certain columns like name, type, price, and size, because we really don't need the ID or the date. Okay, let's see. Okay, so we're showing just the tail of that data set. 1, 2, 3, 4, 5 last rows. And the function GT, as I mentioned earlier, specialized object, it enhances the functionality of the table. So first, let's convert our pandas data frame into Great Tables table to see the difference. So the font is larger, it's just visually more presentable, and something that we are more used to seeing in a traditional sense table. So next, I'm going to show you how to add title and subtitle. So for that, there's a tab header method from GT function. So this function accepts title and subtitle arguments. So, and here is the output of this function. So for example, here we're adding title and subtitle. So next, I'm going to show you how to insert footer. So there's this tab source note function. So we can change, within that function, we can change the, here, let me just show you first. So we can change the font. So for example, by enclosing some certain text in double stars on both sides of the collection, we are making it bold. For example, data source here. So you see 2 stars, 2 stars. Tutorial right here, 2 stars, 2 stars. So that makes it bold. Then we can italicize certain parts of our code, like for example, Python graph gallery right here. If you enclose the text in single star on each side, that makes it italicized. And then also by enclosing it in comma, I'm sorry, in apostrophe on each side, it makes it code-like. looking like here. Grade tables right here. Okay, next I can show you how we add certain color to chosen cells, and this is actually a lot of fun. So for that we need to import functions style and lock. So let's see, let's run the code first to show you what the output is first, so I can refer to the code later. So let's see, the first part of the code, unfortunately, unlike in R where you can just add code and build onto the previous line, in Python you would have to copy that code to get the output. So you can just, unless you do it in separate cells, but for the same cell you kind of have to start over. So we'll copy the code and we'll create the table with that header and footer. And this part here will show you how to fill color, how to change color or style of certain cells only. So for that, we're going to show the location of the cell first. For example, here, location would be column price and row Mexicana pizza. So at the intersection of price and Mexicana, we have this cell here, 2025. So we set the color. And as you remember, we can do this in any order. So we can just set location first and style next, or vice versa. So we choose to set the color to this, I don't know, brownish, orangish color. So, and it's designated as pound C5ECEB. So, and that code will turn the color of the cell into this particular color. Next, we'll choose the cell at the intersection of price and chicken Alfredo. So price, chicken Alfredo, see we made it bold. And we increased the size of the font. So this is where we do it. So we just literally define it as bold. And weight is the font. And the size is 20px. So that enlarges the size of this text to larger. And then finally, this is the code right here for creating a frame around the cell. So first location would be column type and row 3, which would be actually 0, 1, 2, 3, because we start with 0. So that would be veggie. And we define the style and the color of the border right here. So the position would be top and left, top and left. And weight is 3px, that refers to the thickness of that line here. The color is red, as you can see here. So next I'm going to show you some more advanced stuff, how to so the table below has six different methods applied, including a handy stop component that emphasizes the row labels. Grouping of rows will be generated via categorical values in a column. We'll add a table title, also subtitle, with the method tab header, which I already showed you previously. And the numerical values will be formatted with FMT, which is format integer, and format currency. So column labels will be enhanced via method calls label, and the source node will be included through the use of the method tab source node. So let's run this code and see what we have here. Okay, so there you go. So if we look into this code, what we got here is, okay, so let's see. So first we're filtering. So we're just getting manufacturer, model, year, horsepower, torque, I believe, which I'm not sure what that means, and MSRP, so price. So 10 entries from the bottom of that data set. And we create those labels. Performance would be our spanner. So that spans across 1, 2, 3, basically all the columns here on top. Then, oh no, I'm sorry. So it spans over columns HP and torque, which is defined right here. Then tab header. So for the header, this is where we define the header. And we made this GT cars in bold. And subtitle will be defined right here. Right here, small selection of great cars. So now column label is year produced, HP, torque, and price. So we formatted as integer for columns year, HP, and torque, and we're not using any separators. So we format the last column to show the $sign. So by adding format currency, columns MSRP. And finally, we're adding the footnote right here. Here's the code for it. So source the GT cars dataset within the grade tables package. So it's listed right here. So next, let's run this example, advanced example number 2. Okay, so in this example, we'll use the air quality dataset included in the package as well. So yeah, that's the fourth dataset that I used in my tutorial. So in this table, we have 2 spanner labels with tab spanner. So right here. So the label of the spanner is date, and it spans over columns year, month, and day, as we can see right here. The second spanner label is named measurement, and it spans over columns ozone, solar R, wind, and temp right here. So columns year, month, and day, we move it to start, so in front of our other columns, so year, month, and day. Now, so we define the header of the column here. We can see it right here. And we added subtitles. And finally, let me see what we're doing here with column label. Oh, there you go. So for the units. So for ozone, so this is the unit of ozone measurement defined right here. Miles per hour for wind. Temperature will be in degrees Fahrenheit. And finally, solar. And as you can see, it can be really defined in any order, not necessarily the order that columns are listed here. So yeah, so that is that example. So for formatting table cells, there are 11 format or FMT methods. And here they are. So format number, it will format numeric values. Format integer will format values as integers. Format percent. So it will display values as percentages. Then scientific formatting will be scientific notation, for example, 10 to the second, 10 to the fourth power, and so on and so forth. Currency will format value, and bytes, Roman numerals, dates, times. Format markdown will be displayed as markdown text, and format function will set a column format with the formatting function, basically. So the basic idea behind the formatting implementation was to make formatting an easy task, but also to provide the user with a lot of power through mixing and matching several options. Most of these methods have a locale argument, which allows for numbers, dates, and times to be easily displayed in locally specific ways. For example, when we set currency here, so because we didn't set locale, it was by default, it used English or $signs, or not even sure if it's called imperial or, yeah, I guess metrics. So, and if we set, I'll show you later how to change the locale to display basically other countries' formats for date, time, months, and so on and so forth. We'll have an example like that. So it makes it very versatile and very basically universal for no matter what country you're in, you can use this package. So here I can show you another example of formatting with the slightly smaller version of Exable dataset to show you how we can change lookup. So here, first we're going to just get 4 rows of the Exable dataset, and we'll call it Exable smaller. So we will format the date in the column date to style. Here, weekday, Thursday, January 15th, month, day, year. So here, Thursday, January 15th, 2015. Then when we format date in rows 2 and 3, so we can specify certain rows for certain formats. So, see, all 4 rows are formatted completely differently. So rows 2 and 3 are formatted in style day, month, and year. So day, month, and year. And by the way, row 2 and 3, don't forget, since we start with 0, so 0, 1, 2, 3. Therefore, it's not this 2 and 3, it's this 2 and 3. And here you can see we set the locale to DECH, which represents, I think it's Deutsche Confederation Hellenica, which stands for Switzerland. So it's basically Swiss German. And so when we format the time in column time, we set it to style hour, minute, second, and AM or PM. So in our case, it's PM. So that's a pretty cool function. It's, it's very easy, so you don't have to really worry about messing up your code. So if you don't know how to do one part, you can still figure out later just by layering and adding layer on top of the layer on top of the layer, just like R does. And once again, as I mentioned before, you can just kind of bring all this code together. Look at this, it will do the same thing. This, if this is, but then the rows become so enormously long that it's visually easier to just separate them. So anyway, here, see, it does the same thing. And here I want to show you 5 really, really advanced examples with code. And just like in previous examples, we're going to use built-in datasets. So here, although we already import folders, okay, so we'll import the same create table special object, markdown, HTML, and then we will import dataset islands. So we'll get some part of islands dataset just for the sake of space, I guess. And here by running this code, I will show you what this great package can do. So large land masses of the world. So I already showed you how to set title, subtitle, which by default you don't have to really manipulate the size. It will, by default, title will always have larger font than subtitle. Then, so let's see what we have here. So stub, source note, and source note. So here we're referring to source notes here. So you can list source and reference. And so here, reference, source. So row, column, let's see, row name, column is name. Okay, and then so the stub had label as landmass, and basically column size we formatted to integer, so there are no decimals left. Now let's run this example here. So this will show us the example of what we can do with air quality data set. So we are getting 10 values from the data set from the year of 1973. So see how easy it is to pull certain values if you know the columns of the data set. So next we will, so you see we have header, we have title, we have subtitle, then we have 2 spanners here. So we have spanner time, So once again, here's how we set it. So it spans over year, month, and day column. And then the second spanner is measurement that spans over 4 columns: ozone, solar, wind, and temperature. And I already showed you how to set the units, but this block here will set the units for those 4 tables. And we're moving those columns to start. And then next, okay, so this is a more complicated table. Population of Oceania countries in 2000, 2010, and 2020. So for that, so we're importing dataset country pops, which stands for country populations. So we export certain functions here, and so now we assigned 2-letter country codes for each region of Oceania, including Australia, Melanesia, Micronesia, and Polynesia. Wow, I didn't even know that Melanesia and Micronesia existed. So now we create a dictionary. So as you can see, you can incorporate normal methods and everything you know about Python into this code. So we're still working with dictionary, mapping country to region. For example, AU would be Australia. So here's our dictionary. So for region, countries and Oceania, items for country and countries. So this is how we assign our dictionary. So now, let's see, wide populations from pandas, country pops filter. Okay, so we're filtering out years 2000, 2010, and 2020. And we are replacing the country with country code, with the region actually. And we are actually doing some grouping here. So here is Australasia, that's our group. Melanesia, Polynesia, Micronesia. So this is how we perform grouping by region. And let's see, so the header, we set the header, we set the spanner, and let's see, depth down, country name. Okay, and group name, column region. Okay, so this is how we set the group name, and this is how we set here row name, columns, country name. And also we finally format our data to display in integers. Okay, and here is one more table. Let me see. So built-in dataset Townie. Oh wow, actually there are more than 4 datasets that I'm working with in this tutorial. Okay, so once again, we are only downloading certain values from the full dataset. So we'll stick to 10 rows. And let's see what we're doing here. Location. Okay. Okay, let's see. So see, we can include hyperlink in reference to the location on the map, which is super cool. And we can include websites for each municipality. Okay. And finally, this is a really cool example of using colors. So for this, we are importing our built-in dataset SZA. Okay, and it has something to do with solar zenith angles, it looks like. So it's months of the year from January to December, and this is the time of day from 5:30 a.m. until 12. Okay, which would be 12 p.m. Okay. All right, so now, so let me see what we have here. Drop them. So we can actually pre-process our values right here within the methods. Okay, and then this is a good example of using color palette. So we can use, or we can set the, so here's the palette, our colors: purple, Rebecca purple, white, and orange. So it's a combination of 3 colors. And we have header, we have our subtitle, and so we substitute missing text with just empty space here, so nothing is shown. Okay, so all those examples were basically searched and gathered from a few sources, and here's a reference to all 4 of them, so you can click on those hyperlinks and further explore the content of this tutorial. And this is it for today. Thank you very much.